coming back to the topic of operational efficiency, although it is talked of a lot, but we still are perhaps in a learning phase with this energy transition as to how you realize this operational efficiency all around. Perhaps, say some years ago, it was as easy as if you are operating a thermal power plant, you operate it on base load. You know what heat rate is supposed to be maintained, what auxiliary power consumption is supposed to be maintained. So your concentration remained to be limited to certain things. You became a generator which was continuously generating, say, 600 megawatts. So you continue to operate at 600 megawatt with minor variations. Here and there are some interruptions that you may see. With largely renewable integrations, the problem has become multifold, whereby the entire transition over the day is to be taken by a thermal power plant generator. It is not only because the grid requires, it is also because the price does not become tenable anymore beyond that. What happens is, if you look at when RE becomes available, which is largely solar, out of the 280 gigawatt that is told. So when the transition starts, say in the summer months, as of now, the transition starts as early as 7:38. That is where your solar starts getting in, and it peaks by around 9. So that changes in summer. In winter it was around 11 o'clock, and it goes right up to the evening 5:30, depending how much the sun is. With the kind of heat that we are seeing, the generation remains higher. Many a times the switchover or upsets are quite big than we think of. Like we had an upset only few days ago. We had two upsets sort of whereby solar generation was lost, and that led to grid upset. First was when there was a problem in Rajasthan, whereby it led to a continued variation in voltage and frequency, where many other generators were affected. Secondly, it was very recently, that was as early as near as last week, whereby Khavda generation was affected, which is a large area of Kutch, which provides huge solar generation. It got cut off, and that again led to grid frequency going down to 49.37, which has not been seen there for a long time. So entire dynamics of power generation is changing. So one needs to adapt to the changing circumstances. So now the next question is, how do you adapt to it? What all do you do? And again, coupled with all this, if you are running a thermal power plant, you have got a change in regulatory norms. Norms have not changed, but the compliance, the way the compliance was looked at, it is changed. Now you have your emission parameters directly shared with the Central Pollution Control Board. So it is under direct monitoring. So there are certain provisions under which if your exigencies increase, you will be penalized, you will be issued notices. So such problems are there which also need to be taken care. Furthermore, there is a mandate which says that you have to use some amount of non-fossil fuel like biomass in your boilers. So that is another challenge. So at this stage, we have got multifold challenge. If you happen to be a thermal power plant operator, so you happen to see multiple challenges. As being a renewable operator, rightly said by Baldev Saab he was telling that there are grid limitations. Just to get things on record for people to understand, in 3 months, which were not like solar months, sort of, we can say, from January to March, there are 300 gigawatt hour of solar generation that could not be utilized because of grid limitations. Over a day, that number exceeded 34 gigawatt hours. So that was something you had to make up from thermal, just because that grid infrastructure was not available to support that. So grid infrastructure needs a rapid growth, but again, a small understanding while we talk of that also, the grid infrastructure is something which takes 36 to 48 months to come if there is an upgradation that is to come in. Whereas setting up a RE power plant, it is a job of 12 to 18 months under current circumstances. That is where, with things in place, you can get with generation in 18 months. So you can understand how fast that RE can be ramped up. And yes, we are ramping up much faster, and we have been able to get, at least in terms of solar, lot of things are being done. In wind, yes, the area has been expanded, and a lot of other things are getting it as far as renewable is concerned. Now, coming back to the topic of thermal power plant, what do you do now? it is like you have to reduce generation. This compulsorily your generation reduces to 55% of your base load, or the minimum, technical minimum that you can go. It is easily said, equipments are meant for that, right? But a thermal cycling that your plant is supposed to see every day. Every day you will reduce the generation, every day you'll increase the generation. There'll be a thermal cycling that will be seen by your boilers. There'll be a thermal cycling that will still be seen by your steam turbines. Plus, whatever firing you are doing in terms of biomass and whatever it is, you need to control your emission parameters while these generation changes, and these changes quite often are sudden. You'll observe that the frequency that changes or the generation change that is there, you can observe if you look at whatever is that grid rates that are available. See, I have seen a grid rate being available at 30 paisa per kilowatt. See, you can say 30 paisa per kilowatt is not a sustainable number, but yes, since things are excess, it goes right up to that. So now what I need to find out as a thermal power generator is how can I back up? How can I bring down my cost? How can I avoid interruptions while I change over, while I reduce my generation, while I increase my generation? I need to depute AI. I need to use my digital twins to find out historically what is happening to my boiler, what is historically happening to my turbine, so as to predict whatever maintenance may be required that may be coming earlier than it was scheduled. Additionally, if I am a thermal power operator, current energy crisis tells you that thermal power plant operation is something that has sustained our own energy sector in spite of lot of crisis in energy availability from the Gulf. So largely because we are dependent on something that was from thermal, additionally with from RE, both of them has helped us make up through this. So yes, we need to sustain this change. This may perhaps require some support from the government in terms of wherever there are loss of efficiencies because of lower load operation, wherever there is a loss of heat rate because of lower load operation, that needs to be compensated by the government. To some extent, biomass inefficiencies, government has been ready to absorb. But I'm not sure as of now, I'm not educated on that in terms of whether thermal power, any anything has been given to them to absorb these inefficiencies. So that will have to get in. So as a future, what should we see it? We should look at large scale private sector investments being propelled by the government into grid infrastructure. That will involve availability of large amount of RE power, which is a must even today. Not that the thermal has a long way to go. Thermal will still be there. Thermal will sustain only through the peaks. But other than that, yes, you need solar generation, you need RE generation. RE generation again coupled with battery energy storage. See, if you are unable to put it in the grid, you store in the battery and then you supply in off-peak hours. You have got hydropower storage. So that amount is that is also there. So there are different aspects on which people are working. Although something when we say battery storage, it's not a completely matured sort of technology that remains all around. Yes, a lot has to be done to bring down the cost of battery energy storage or any other energy storage system that needs to get in for a balanced power supply that needs to be made available to the customer throughout. And the preferred one will be everybody will be looking at why not get grid power at a frequency which remains between, say, under best of circumstances, you will want that frequency to vary between 49.8 to 50.1. So that is where you will look at ideally on a grid. If you are an industry, then also you'll look at that way. If you are not an industry, you also look at that things remain stable, your voltages remain stable. So that is where your functional efficiency will improve in terms of your equipments also. So for all these things to come, there are multiple things. Yes, we are in through a transition. We are not through an energy transition that has gone. Energy transition is long way to go, whereby all this will get as a part of it, whether how to absorb that inefficiency, whether I can make certain changes, whether I can put another set of coils, whether I can put another smaller boiler that helps me sail through. What happens and how economical it is, what all do we do? How do we do the AI such that doing it at one place, it can be imitated at many places? How can I load my generators so that not all equipments get affected? what all can I get in terms of leverage, in terms of any SEMS parameter, there's quality emission parameters that are there. For that, what can I get? What concessions will the government give? Yes, government being the largest operator will, or the largest affected party, it is the government which is supposed to take all policy decisions, which will obviously help this improvement. Then only things can get further. Till that time, we have to work on whatever we have in hand in terms of whatever improvements that we can make, whatever efficiency improvements that we can make. See, simply one can sit, I can slightly take you to a sort of example. We have got a small distribution station nearby, which is a LILO arrangement. This is line in, line out arrangement. It is SUVA in the H. The problem at this place is every day almost it gets saturated during daytime. Now, if you are connected to this area, you'll still have to wait if you want additional power. You are being allowed by the government to get connected to central transmission utility, but yes, the load in this area is also increasing. These are realities. This is an industrial area that has been brought up by government, a 250 square kilometer PCPIR. Still lot of industries coming up, still lot of power demand will be there. Yes, government may be having things that are coming up, but it is still a while before those things mature and come up. There is a mismatch in timeline. So all these things all around need to be addressed, and we as users need to understand that we are through a transition which may bring certain difficulties more than whatever we have envisaged, or within whatever we can envisage to best of our abilities, to the best utilization of AI, predictability, or best utilization of our experienced professionals all around who can tell you, okay, this was there that existed long ago when we are connected to 66 kV, that's this what used to happen. When we are connected to 220, this is what used to happen. Now we are connected to 400, so this is the way it should happen. This is where you should get connected. This is where the congestion remains limited. So all those things will come up from experienced professional, not only AI. AI may help us get those decisions, but may not completely replace experiences that we have. So I believe that yes, the way forward is difficult, but yes, I also believe that we have got strong capabilities well within our own country, which can drive us through and will sustain through whatever difficulties we find out in having energy efficient power supply right to the consumer's gate. That's all. Thank you.